Welcome to this short video that I've called No Half Almond, and I really like this phrase because I think it gives you a very clear geometric, visual, graphical way for thinking about if you're at an optimal bundle for the consumer. So the most common way you hear from the book and in section and in the helpful hints is that the optimal bundle is where the price ratio equals the marginal rate of substitution. Unfortunately, that doesn't give you a whole lot of intuition about either why that's the optimal point or how you could recognize it on a graph. So what I want to do here is let's think about the point A, and I'll label A. So this point on my budget constraint, is that the best point that I could pick that's within my budget? So the best point along my budget constraint. I've drawn an indifference curve through it already, and this half almond shape exists, right? You can see it. Greg is going to show you the full almond later on in a week or so, or maybe you've already seen it depending on when you're watching this video. And the rule is no half almond, because whenever you see a half almond shape like this, I'm going to show you a trick that you can use to get even more utility than you're currently getting. And thus you can use this trick to prove that if a half almond exists, you can do better, and thus you can't be at the optimal point because you can keep doing better. So let's say that we move from point A1 to point A2, let me get my pen, A2. A2 is on the same indifference curve, so it's just as good as A1, but notice how now we're no longer on the budget constraint. So we've freed up some money. We've moved to a point with just as much utility along the edge of the almond, but that's cheaper. And now we can take that money that we've saved, and since we're going to spend all of our money because we're going to be dead tomorrow or whatever, let's go ahead and spend it. And since we spend it, we can get more of both goods and thus be at a better point, a point like B. And now we can draw an indifference curve through point B, and suppose it looks like this. Well, we still have another half almond, so we can apply the same trick. Let's move from point, we'll label B, B1, move to a point that I'll call B2. Now that is on the indifference curve, so it gives us the same utility. We're just as happy at B2 as at B1, but we've saved a little bit of money, so we can make the jump to a point like C and move to a higher indifference curve. And basically, as long as we have a half almond shape, which is no longer true at C, we keep doing this trick over and over and over until we get to a point like C where there is no half almond, and thus we can't use the trick. And at that point, we've reached our optimal bundle. And you can see at this optimal point that the indifference curve is tangent to the budget constraint. So that's where we get indifference curve slope is marginal rate of substitution, budget constraint slope is the price ratio, px over py. So those two slopes match, so MRS equals price ratio. But let's go ahead and write that out and try to think about a better way for maybe intuitively thinking about why this is a good point to be at. So we have price ratio equals MRS, giving up y in order to gain x. The price ratio is px over py. Remember, don't get that backwards. Don't do py over px. I know it's tempting, but don't do it. And our marginal rate of substitution we saw in class is actually really our ratio of marginal utilities. It's marginal utility of x over marginal utility of y. Now we've got things that are maybe a little bit easier to interpret. This tells us something about the prices versus the marginal utilities. Marginal utilities like how much you gain, prices are how much you spend. It's kind of like a marginal cost versus marginal benefit thing like we saw with firms. We saw marginal revenue versus marginal cost. But we're not quite at a point where we can interpret it easily. The last thing we need to do is cross multiply. So we bring the px down here, bring the muy up here, and by cross multiplying we end up with mux over px equals muy over py. And this, I think, is fairly easy to interpret. It basically says the extra utility per dollar from purchasing X is going to match the extra utility per dollar from spending on Y. So you can't get more value per dollar by spending, by taking away from X and buying Y. You're not going to add any value because the values at the margin is equal. You can't switch from Y to X because they each give you equal value. Note, this is not saying that the marginal utility from one extra unit of x is going to match the marginal utility from one extra unit of y. If x is a lot more expensive than y, then you're going to get a lot more utility from an extra x, but not more utility per dollar. It's more utility for more dollars, so the same value. Sometimes people call this the bang for the buck principle. If you're not familiar with that idiom, you can come up with your own name. But basically, something that captures the idea of value from x should match marginal value from x should match marginal value from y. So in this lecture, we've looked at how the no half almond rule tells us geometrically, visually, whether we're at an optimal point. If there's an almond, you use the trick where you move down along the edge to get the same utility but save some money. Then you spend that money to jump onto the back onto the budget constraint but at a higher level of utility. And you keep doing this until you reach a point where there's no half almond and thus you're at the optimum. And then we interpreted that point where you are at the optimal is a tangency point, so it's where price ratio equals marginal rate of substitution. It's hard to interpret that equation, so we rearranged it a little bit and got this bang for the buck rule. Marginal value from x equals marginal value from y, and this gives us now two ways for thinking about our optimal bundle. We have the geometry and the algebra, and finally, in the book, you get a lot of the economic sort of plain English interpretation. So that's three ways overall of looking at this optimal bundle. Thanks for watching.